Welcome to Byte-Sized Tech, where we blend casual conversations with insightful discussions on the latest in technology and gadgets. Today, we're peeling back the layers on two really different, but I think equally compelling stories from the tech world. It's a bit of a roller coaster, actually. One story highlights a pretty surprising vulnerability in a widely used app, kind of a stark reminder of digital risks. Then we pivot to something more proactive, a leap forward from Google, introducing this powerful new tool designed to make the software we all rely on inherently safer. So it's a journey that moves from a cautionary oops to maybe a more hopeful aha in the ever-evolving landscape of data and code.
Indeed. It's a perfect illustration of just how intricate and well interconnected our digital lives have become. Whether you're a developer actually crafting code or simply, someone using an app on your phone, these developments impact you directly. We're going to really dig into the specifics of each incident and innovation, then try and connect them to the broader picture of why this all truly matters for our collective digital security and, personal privacy.
Okay, let's kick off with that stark reminder of digital vulnerabilities.
Yeah.
A story that really underlines why confidential can sometimes be a dangerous promise.
Yeah.
Imagine an app, riding high in popularity, marketed specifically for sensitive confidential discussions among women. It was trending right at the very top of Apple's free app charts, millions of users.
Mm-hmm.
On the surface, it sounded incredibly promising.
Yeah.
A safe space, right, for intimate conversations.
Mm-hmm.
But then, as so often happens in the digital world, disaster struck. And in a way I don't think anyone quite expected.
What's truly striking about this incident involving the app known as T is the sheer scale and the deeply personal nature of the exposed data. It wasn't just a small leak. The app was hit with a significant data breach. We're talking over 72,000 images exposed.
72,000, wow.
Yeah, think about that number. And within those images, approximately 13,000 were selfies of users incredibly personal, obviously identifiable. And maybe even more concerning, the breach included many photos of users' government IDs, submitted during registration.
Oh, wow. IDs, too.
Yeah, which is essentially handing over keys to personal identity.
Wait, it gets even more concerning, doesn't it? Like, as if the image leak wasn't bad enough, there was the second discovery, just days later.
That's right. Just when you thought maybe the full extent was known, another server connected to the app was found, and this one contained the contents of over 1 million private user messages.
1 million private
million, yeah. This raises an absolutely critical question about the integrity of an app specifically designed, specifically marketed for confidential, sensitive discussions. For users who trusted this platform with their, deepest thoughts and private conversations, this was a profound betrayal. It's like a digital diary suddenly flung open. It really highlights how devastating a breach can be when the core promise of an application privacy is just shattered like that.
So, given the magnitude, right, and the sensitive nature of the data, what kind of sophisticated high-tech cyber attack brought this app down? Was it some, shadowy hacker group with zero-day exploits, like something out of a movie?
Well, what's often overlooked in these situations, maybe surprisingly, is that the most impactful breaches aren't always the most technically complex. In this case, the issue was fundamentally due to poorly configured servers.
Oh, really? Just configuration?
Yeah, we're talking about basic setup errors. Mistakes that left vast amounts of data accessible via, unauthorized calls.
Yes.
Anyone could basically just ask for it. This wasn't some complex zero-day exploit that required extraordinary hacking skill. It was more akin to, leaving the digital front door wide open on the internet. It underscores a crucial point. Often the simplest oversights in security fundamentals, the basics, can lead to the most massive and damaging exposures of private data. It serves as a stark reminder that even the most innovative apps need a really robust foundation of basic security practices.
Okay, here's where it gets truly unsettling for me, and something the source material really pushed me to think about. There was this fascinating and, frankly, kind of disturbing debate that emerged around this incident. Some voices in the discussion argued that this wasn't a real hack, or that it was somehow trivial.
Trivial.
Why?
Because it involved women's personal photos and private messages rather than, say, credit card numbers or social security numbers.
Right. If we connect this to the bigger picture, this debate isn't just about a specific app. It's a stark mirror. It reflects how society, and perhaps even parts of the tech and legal communities, often value different types of data differently. The source makes a really powerful point here. If this breach had involved millions of credit card numbers or SSNs, the public outcry would likely be deafening, right?
Absolutely. Headlines everywhere. Immediate action.
Exactly, and the legal ramifications, immediate and severe. But when the compromised data consists of intimate selfies, private conversations, personal IDs, the perception and, well, consequently the response often seem to be different. This isn't just a technical distinction. It feels like a profound societal one. It forces us to confront a bias. Is a woman's privacy, her intimate thoughts, her identity somehow less valuable, less deserving of protection than financial information?
That's a heavy question. It is. And what this incident unequivocally highlights is that it is a hack. It is a serious data breach, regardless of the type of sensitive information involved. The privacy of personal images, private messages, it holds immense intrinsic value, especially on an app that was explicitly built on a promise of confidentiality. The very nature of this app was its commitment to a safe space, and that trust was just fundamentally shattered.
So what does this all mean for you, our listener, as you navigate your digital life every day? It's a powerful, maybe sobering reminder that confidential or private doesn't automatically mean secure. You can't just assume. The value of your personal privacy in any form, from a candid selfie to a fleeting thought shared in a message, you should be taken with the utmost seriousness. Every piece of your digital footprint holds inherent value, and its compromise should absolutely be treated with the seriousness it deserves, regardless of any societal biases. But, okay, it's not all grim news and cautionary tales today. Our next story pivots to a significant stride forward. We're seeing tech giants like Google proactively tackling a stealthier kind of threat. So we're moving from the oops of a basic configuration error to maybe the aha of an innovative solution. Let's talk about Google's recent and significant stand in the ongoing fight against a type of threat that's becoming increasingly pervasive: software supply chain attacks.
Right. And what's truly fascinating here is Google's strategic foresight. They've observed a dramatic increase in these software supply chain attacks over recent years. To give you some context, imagine you're building a house. You don't make every single brick yourself, right? Or every nail, every piece of wood.
No, of course not. You rely on suppliers.
Exactly. Software is much the same. Most modern applications are built using countless pre-existing components. Many of these are open source code that's freely available, developed collaboratively by communities worldwide. This open source code, it powers almost everything. Your web browser, the OS on your phone.
Yeah, it's everywhere, even if you don't realize it.
It really is. Popular languages like JavaScript, Python, down to tiny libraries embedded in your smart devices, it's all built on this shared foundation. The challenge arises because while open source is incredibly powerful and efficient, it also introduces this vast network of dependencies, like a huge chain. And if a single, seemingly innocuous component somewhere deep in that supply chain gets compromised, maybe someone injects malicious code during its creation or distribution, it can silently infect thousands, potentially millions of applications that use it.
Wow. Like a single poison ingredient spoiling the whole batch.
Precisely. It's a really potent attack vector. So Google identified this critical need for a more deterministic and more verifiable way to evaluate the integrity of these open source packages. We need to know the ingredients are safe.
And their answer to this growing threat is this new tool called OSS Rebuild, right? Was its core mission.
Yeah.
How does it actually aim to solve this complex problem of trust in the software supply chain?
Exactly. OSS Rebuild. It's designed to fundamentally bolster confidence in open source projects. Its mission is really to empower the security community, developers, everyone, to gain a deep, verifiable understanding and, crucially, control over their software supply chains. Their aim is to make consuming an open source package, just using it in your project, as transparent and trustworthy as if you were pulling the source code directly from its original repository and building it yourself from scratch.
Okay.
This raises that really important question. How can we truly trust the software we use every day if we don't know exactly what goes into building it? Or if every single component along its journey, from source code to final product, is legitimate and untampered? OSS Rebuild is trying to bridge that profound trust gap with hard, verifiable evidence.
That transparency sounds absolutely crucial, especially now with these supply chain attacks being so devious. But how does the tool actually work? How does it achieve that level of deep scrutiny and verifiable trust? Sounds complicated.
It leverages some clever techniques. The Rebuild platform achieves this transparency through a combination of powerful features, each designed to monitor and verify the software's construction. First, it uses what's called a declarative build process. Think of this like a super precise recipe. You define exactly what should be built, not just the general steps. Makes it predictable, reproducible.
Got it, like a detailed blueprint.
Exactly. Second, it employs build instrumentation. This is like having highly sensitive sensors monitoring every single action during the software's assembly. It meticulously collects data on every command, every file accessed, every component used, creates a kind of forensic record.
Okay, tracking everything.
And third, it includes network monitoring capabilities. This ensures that only approved and verified components are pulled into the build process, preventing any unauthorized or potentially malicious external connections during the build. All of this operates within the SLSA build framework that stands for supply chain levels for software artifacts. It's a set of robust industry standards, Google helped pioneer them actually, to certify software integrity.
SLSA. Okay.
And the output of all this rigorous oversight is what they call fine-grained, durable, trustworthy security metadata. Essentially, it's a cryptographic fingerprint of the software's entire journey. Makes it incredibly difficult for anything malicious to be hidden or tampered with undetected.
Wow, that's a mouthful of technical terms. But the practical outcome, this meticulous, verifiable record that sounds like a potential game changer. So what kind of sneaky stuff is it designed to expose? The kind of things hackers might try to slip into our software without us knowing.
Precisely. This tool is specifically engineered to help detect several critical issues that could compromise software integrity and introduce those hidden vulnerabilities. For instance, it can detect build environment compromises. So if someone has tampered with the actual system where the software was compiled, this tool should spot it.
Right.
It's also designed to unearth potentially introduced backdoors, hidden pathways or secret entry points intentionally left in the code for unauthorized access later. Vary. Beyond that, it helps identify unsubmitted user code, basically, code that's been added to a project without proper approval or review processes. Sneaked in. And finally, it can catch instances where code isn't actually present in the public repository it claims to be from. So a mismatch between what's promised and what's actually delivered prevents malicious code masquerading as legitimate open source stuff.
So, okay, boiling it down. If I'm just someone using my favorite apps on my phone, or working on my laptop, maybe without even realizing how much open source code is running in the background. What does this all mean for me? How does Google's OSS Rebuild actually impact my daily digital life?
Well, if we connect this back to the bigger picture for you, the end user, it means significantly greater confidence, greater trust in the underlying components of the software you rely on every single day. While you might not be directly interacting with OSS Rebuild yourself, its existence and adoption are, frankly, monumental for the entire digital ecosystem. By securing the foundational elements, those open source building blocks from the ground up, it makes the apps, the services, the operating systems you interact with far less vulnerable to these stealthy supply chain attacks.
So it's like strengthening the foundations of everything.
Exactly. It's a proactive, preventative measure. It reduces the risk of malicious code making its way into the products you ultimately use. Think of it as Google and the security community building a much stronger, verifiable foundation beneath everything, allowing you and developers to build and use software with more peace of mind. It truly is a huge step towards making open source software, which is everywhere, more secure for everyone.
And for those who are really keen to dig deeper into the technical side, maybe even contribute, it's available on GitHub, right?
That's right. It's out there for the community to use and improve.
Okay. So today, we've taken quite a journey through two very different but equally important facets of our digital world. We started with that stark reminder of personal data vulnerabilities, seeing how even simple oversights can lead to really profound breaches of trust and privacy, especially, as you pointed out, when societal biases about data valuation come into play. Then we shifted gears to explore an exciting new development with Google's OSS Rebuild, a powerful, proactive tool aimed at making the very fabric of our software more trustworthy and secure. It's definitely a constantly evolving landscape. Demands our attention.
Indeed. While that first story might make you wary, and it really highlights the ongoing need for extreme caution with personal data and vigilance about where you share it, the second story offers a crucial glimpse into how the tech community is actively working to build more secure foundations, striving for greater transparency, greater integrity in the very software we all depend on. Both stories, really, in their own way, highlight the critical role of vigilance, whether you're developing software yourself or simply using it day to day.
So the final thought then. What does this all mean for you, listening right now, beyond just being informed? In a world where our lives are increasingly digital, where our data is seemingly everywhere, What responsibility do we as users truly have in understanding these risks? Maybe more importantly, how can we best support the solutions being built to protect us? Is it enough to just be aware? Or should we be more active maybe in advocating for stronger privacy standards, better security practices from the companies whose products we use? Something to mull over until our next chat. Thanks for tuning in to Byte-Sized Tech. If you enjoyed the episode, like, comment, share, and subscribe for more fun tech discussions.